I want to go back to casting again. A long, long time ago, I showed you how to cast with the round brackets. So you have a floating point number and you write round bracket int round bracket and then the floating point number, and then that casts it to an integer. Maybe throws away the part of the number that was after the decimal point. You don't get a warning because, hey, you told the compiler you knew what you were doing. You can use round cast to go back and forth between different kinds of pointers, different kinds of references, but it's kind of a dangerous thing to do. There's nothing to check to see that it's okay what you're doing. And when someone else reads over your code, they may not understand what you're doing or why you're doing it. Very often people end up putting comments like, this is okay because I know it actually has a tweeter in it. There are better casts available to you, and now that you understand template syntax, you can use them. Here is the static cast. It's a template. It's an operator called static cast, angle bracket, whatever you want to cast to. And it's done at compile time. If at compile time the compiler doesn't see a relationship between what something's really pointing to and what you're trying to cast it to, or in the case of numbers, the kind of number it really holds and the kind of number you're trying to cast it to, you will get a warning, or in some cases an error, that they're incompatible. But if it could sometimes hold this kind of information and could sometimes hold that kind of information, you can be tripped up by a static cast because there are no runtime checks to help you out. The dynamic cast has a runtime check, and the runtime check relies on knowing what the type is at runtime. It's restricted to working with pointers to objects of classes that have virtual tables. The cool thing about a dynamic cast is that when you're trying to cast to a pointer, if it doesn't work, because at runtime it can be established that that's not really pointing to a tweeter, you get back a null pointer. And you can test against a null pointer. If you're trying to cast to a reference, it'll throw an exception. That's okay too. They're slower to use the dynamic cast, but it's safer. You won't ever misinterpret bits and cause really weird bugs of the kind that you can get when you misuse a static cast. Now, for the sake of completeness, I'll also mention const cast. I'm not showing you the exact syntax here. This is where you can actually take a const variable and cast it to a not const variable so you can change it. As you can imagine, not a beginner technique. Sometimes people will do this to handle caches and things like that, where you're not really changing the object. There are other ways to do it. Anyway, not for beginners. Reinterpret cast is totally not for beginners. This is a matter of bit twiddling. This involves knowing how long certain data types are and the pattern of bits inside the data type. And you say, oh yeah, I think of that as being an integer. And then you put some values in it. And they say, no, I'm going to think of it as being something completely different, and ask about its value. And the bits will be interpreted differently. The meaning will be interpreted differently. There is old code that uses reinterpret cast, but what I really use it as is a huge red flag to say, wait a minute, someone's trying to be really smart here. Is that actually necessary? And that's one of the ways that casts can really express your intent. A static cast is nice and safe between two related types, and you're really confident that this person pointer actually points to a tweeter, so you just feel like casting it to a tweeter so you can call some tweeter function. Yay. Dynamic cast, a little less safe, a little bit of a runtime performance hit, but you will be checked on and you will be protected. Const cast, very dangerous, and reinterpret cast, extraordinarily dangerous. This is the shooting your own foot off territory of C++. That's why I'm not going to teach you how to do it. I want you to know that it's there. If you see these casts in someone else's code, tread carefully.